All right, we're talking about Unit 5 review. So this is the same in-class review with maybe minor number changes that you have done for bonus points. So I just wanted to go through and make sure that you are answering these correctly and that you didn't misunderstand something and get them wrong on your review. So the first thing that we want to do is we want to make sure that we can answer examples of natural, whole number, integers, rational, that's an R, and irrational numbers. I want you to realize that all of these are real numbers, all of them. So natural numbers are just our counting numbers. So 1, 2, 3, 4, 5, and so on. Whole numbers are 0 and our counting numbers. Integers are our negative numbers, and then our whole numbers, which is 0, and all of your natural numbers, which are 1, 2, 3, and so on. So I want you to see that the dot, dot, dot before it, all the negative numbers keep going and all the positive numbers keep going. But remember that integers, natural numbers, and whole numbers are all whole numbers, okay? They're not decimals, they're not fractions. Rational numbers are your decimals, your fractions, as long positive or negative, doesn't matter. They can be proper, improper, any of them, as long as the decimals, when you divide them and you get decimals, that your decimals are repeating or terminating. So here's some examples of rational numbers. Okay, irrational numbers are those not so pretty numbers. Pi is a decimal, but it's on the irrational because a pi, or the pi symbol, represents an infinite, ongoing decimal number. It never ends. The only way that you get it to stop is if you round it. So that's why pi is irrational. Okay, the next thing that we need to talk about, let me mention that this was all from 5.1 lecture video and from notes. This one is from 5.6 area, and we're talking about the properties. And so the first one is a commutative property of multiplication. Okay, so this is about the order. We're multiplying, but commutative tells us that we can change the order. So 3 times 6 is the same thing as 6 times 3. So that's an example of the commutative property of multiplication. The distributive property. I hope this is familiar with you, for you, but I want you to see that if you have a number on the outside of the parenthesis, it means that it's multiplied times each thing inside, so it's the same thing as this. And I don't love that we write it for this example with an x, meaning multiply, because we're already talking about x's in this chapter, but for purposes to show an example of what's happening where we're combining the 2 times the 4 and the 2 times the 1, but it's still an addition problem. This is the best example that you can do for that. The next thing is the associative property for addition. Okay. And the associative property for addition just tells us that you have to keep the numbers in the exact same order, but you can regroup them. That's the associative property. So it's 3 plus 4 plus 1, where the 4 and the 1 are grouped, and it's the same thing as 3 plus 4 plus 1, where the 3 and the 4 are grouped. So the 3 plus 4 plus 1 is all in the same order, but the grouping of it is a little bit different. All right, this next one is from 5.2, and this tells us to add. And so I have a negative 12 plus a negative 9. Getting that out of control here. All right, let's do negative. There. So we're adding. It's an addition problem. So I can see that the signs are the same. Both of them are negative. So if it's addition and signs are the same, we're going to add the numbers and keep the sign. So I know that keep the sign is negative. I add these two together and I get a negative 21 as a final answer. Okay, this next point is, or problem is from 5.2, we're subtracting. subtract, and you have a 2/5 minus a negative 4/5. Okay. I look to see that our denominators match. Have to have common denominators if you add and subtract fractions, so I already do. And so I know that the rule is to change the sign to addition and change the sign of the number that follows. And so the new problem that I have is 2/5 plus 4/5. It's an addition problem. Signs are the same. I add and keep the sign. Final answer. Okay, the next problem we have is from section 5.3. It's about multiplication. So I have a 27 over 49 times a negative 14 over 6. Okay, I'm looking to simplify where I can, and I'm going to divide here by 7, and I end up with 2 and 7, because 7 times 7 is 49. Here I can divide by 3. 3 goes into 6 2 times, and 3 goes into 27, oh, sorry, not 2, 3. 3 goes into 27 9 times, because 9 times 3 is 27. Okay, so across the top I have 9 times 2, which is 18. Across the bottom I have 7 times 2 is 14. This guy was negative. So when you're multiplying, you're looking to see if signs are the same, and they're actually not. They're different. So signs are different. The answer is always negative. If they ask you to simplify, then you would divide here, the top and bottom, by both by 2, okay, to simplify one more time, and then you would have your final answer. Okay, the next one is going to be a division problem from section 5.3. This is a negative 60 divided by a negative 3. Multiply and divide. If the signs are the same, the answer is always positive. If they're different, the answer is always negative. So 3 goes into 60 how many times? And your answer is a positive 20. Okay. Next section is 5.5, and it says use the order of operations to simplify. So if we're actually looking to simplify an expression, that means we have no equal sign. So I've got fractions added together, and then I'm going to square it, okay, because I'm supposed to take care of everything in the parentheses first. That means add the fractions, and then the exponents would come first, and so then I would square my answer. So I need a common denominator. So I multiply my denominators that I have together, and I got 6. Multiply the diagonal here, and I get 3, and the diagonal here, and I get 4. Denominators match, so I bring the denominator over, add my numerators, and I get 7. This piece is now the answer in here, so I'm going to then square it. So that means I have 7 6 times 7 6, which gives me 49 36. Final answer. Okay. The next section is 5.6. Oh, I'm sorry, 5.4. Okay. And this section we're going to use the order of operations to simplify the expression. It's a little bit longer than the one we just did. That's a bracket, sorry. 3 minus 6, negative 5 plus 2 squared, in brackets. Okay, so parentheses first, and I get negative 3. Bring down things that I haven't used. Okay, negative 3 squared is a positive 9. Negative 6 times 9, well, negative 6 times 9 is going to give me a negative 54. Okay, bring down my 3 that I haven't used. I subtract here and I get a negative 51. Okay, how did I do that? Well, I changed the sign to addition, changed the sign of the guy that was next to it, and then I look at this problem and I have 3 plus a negative 51, or I'm sorry, 54. It's an addition problem. Signs are different. Subtract and take the sign of the bigger number. Bigger number was negative, so that's how I got negative 51. This is still in the parentheses, and the negative is on the outside, so my final answer is a positive 51. Why? Because this is a negative 1 times a negative 51. 2 negatives make a positive, so 51 is my final answer. Okay. The next one is from section 5.6. We have a negative 2 times x minus 3 squared plus 6. And they tell us that x is going to be 2. So we're going to take out x here. and we're going to put 2 in its place. So here I get, it's a subtraction problem, right? So I have 2 plus a negative 3, right? I change the sign. And so signs are different. Subtract and take the sign of the bigger number, and I end up with negative 1. I'm going to bring down everything that I haven't used. Negative 1 squared is 1. Negative 2 times 1 is negative 2 plus 6. Signs are different. Subtract and take the sign of the bigger number, and so you end up with a final answer of a positive 4. Okay. The next section is another 5.6 that also says to simplify. This time they're not giving you that your letter equals a number. They just tell you to put together things that match. That's what simplifying means. So 19p, negative 19p, negative 3p, positive 8p. They all are a p, which means that they're the same category. They're all girls or they're all boys, or they're the same. So that means that I can add or subtract the numbers in front of the letter. So I'm going to do this from left to right. So this is a problem I have. I change the sign of the one that follows. So I have negative 19 plus a negative 3 is what I have. P will be in part of my answer. I'm just ignoring it for a second, so my numbers is what I'm dealing with. So I look at this and I see that signs are the same, so I'm going to add and keep the sign, and so I end up with a negative 22p. Okay, I have not used this one, so I'm going to bring it down. All right, so I look at this, it's an addition problem. Signs are different, so I subtract and take the sign of the bigger number. And so when I subtract, I end up with a negative 14p. Final answer. I put together things that matched. I added all of those up. Okay. I owed somebody $19. I owed them $3 more. I owe someone now $22. I got $8. I gave that money to them, and now I owe someone $14. Okay, that's what we're dealing with. We're talking about positives and negatives, so that's debts and credits. Okay. The next one is from the 5.9, 5.10 lecture video section. And so this is a multiple step problem. Okay. Step 1 is to do parentheses, and I can't do anything between the x and the 7 because one's a number and one's x. Those are different categories, okay? I don't have any exponents. I can multiply here, so I'm going to multiply here, and I end up with 14x, and a positive and a negative multiplied together give me a negative. Well, 14 times 7, let me see, gives me negative 98. Bring down things that I haven't used. Okay. I'm going to put together things that match on both sides of the equal sign, and so I find these are both whole numbers, right? They have no x's or letters with them. So what I have here are 2 negatives. So I'm going to rewrite this, and I'm going to change the sign, right? I changed it here, changed it here. So it's an addition problem. Signs are the same. Add and keep the sign. And so I end up with negative 110. So I bring down my 14x. I have my negative 110 where I put these two together. I bring down my equal sign, 22x minus 212. Okay. Now my goal is to put the numbers on one side, the letters on the other side. So I'm going to do opposite of what I see here on both sides. Okay, so this is the problem I have. I have negative 212 plus a 110. It's an addition problem. Signs are different, so I'm going to subtract and take the sign of the bigger number. And so 212 minus 110 is going to give me a negative was the bigger number, and so I end up with negative 102. I bring down the things that I haven't used. Okay. And from here, I need to put the letters on the same side, so I'm going to subtract the 22x. Okay, make a little space on the screen for us to be able to finish working this. So here's the problem I have. I have 14x, the minus the 22x is what I just brought over. Okay, So when I put these two together, this is what I'm looking at. I have 14x minus 22x. I'm going to change it to addition, change the sign of the one that follows. So now I have 14 plus a negative 22. Signs are different. Subtract and take the sign of the bigger number. The bigger number was negative 22. And so I subtract 22 and 14, and it looks like I get a negative 8. Bring down negative 102. I divide by negative 8 because that's what I want to get away from my letter. And 8 does not go into 102 evenly, but here's what I do know. I can simplify. Two negatives, when I multiply or divide, two negative signs are the same, the answer is always positive. And I can divide the top and bottom both by 2. And so I end up with 51 over 4. Final answer, positive. Okay. One last problem. This one comes from 5.7. Okay. And this is a one-step problem to solve. Okay. I need to get letters on one side, numbers on the other. I need to do the opposite of what I see here and move this over. R equals 87 minus 32. Make an addition problem, change the sign of the one that follows. So 87 plus a negative 32. Signs are different. Subtract and take the sign of the bigger number. So the answer is going to be a positive. When I subtract, I end up with 55. Final answer. Okay, that's all for our review video. Make sure you contact me with any questions before you take your test.